Alright guys, today we're going to be talking about reflections. We have a couple learning targets today. Our first one is I can draw the image of a figure after a reflection over a line. So we're actually going to be doing the reflection and finding out those coordinate points. Then our second learning target is I can determine the equation of the line of reflection when given a pre-image and image. This should be pre-image right here. So given that we have a pre-image, two figures, and we see that they reflected over a line, we need to actually find this equation. And we're going to be finding the equation in slope-intercept form. So if we recall from Algebra 1, slope-intercept form is y equals mx plus b. The variables that we're going to be looking for in that are m and b. The x and the y will stay the same. So those are our two learning targets that we'll cover today to make sure that we're prepared for our test later on. So to get started, we're just going to talk about reflections. So a reflection over a line often occurs. This is one of our rigid motions. It's one of the more common ones and one of the easier ones. Out of translations, reflections, and rotations, I would say that this is a little bit more difficult than translations, which we just covered in our previous video, but more difficult than rotations. So what happens with these is that we have a line of reflection. So what this line here in the middle is called, that is our line of reflection, this purple line. So I'll go ahead and write that down. That's an important term. The line of reflection is what we reflect over. What I like to think of it as is it's the actual mirror. So ABC, our pre-image, that's me standing in front of the mirror. And I look into the mirror, and on the other side of my reflection, I see A prime, B prime, C prime. This is my reflection. Now some interesting things occur here. The distance from point C to the line of reflection is the same as C prime to the line of reflection. So these two are the exact same distance. The same can be true with A prime. This is the same thing that's happening with A prime. So the distance to both A prime and the line of reflection is the same as from A to the line of reflection. And then you guessed it, we can also do this with B prime and B. So the distance to the line of reflection for both B prime and B is the same distance. These aren't the greatest because my lines are starting to get a little bit crooked, but just know that these are the same distance as well. So each of these segments to the line of reflection from our image or our pre-image, so our pre-image and our image, these are the same distance. So essentially, our line of reflection is the midpoint of segments A prime, C prime, and B prime. In fact, if I can find the midpoints of all of these, I can draw my line of reflection, which will be very useful for us. So again, all of these points are equidistant to this line of reflection. And that's important to know. It's important to know that each of these will be the same distance. All right, so perpendicular lines. Now, again, we talked about midpoints, and it deals with actual perpendicular bisectors, which is occurring here. And we'll talk about these right now, in fact. So perpendicular lines, we should know these from Algebra 1, but they're lines that intersect at right angles, meaning they intersect at 90 degrees. Along with these, we can find that in the figure just based upon the right angle mark. So if you ever see that right angle mark, we automatically know that they're perpendicular, meaning they intersect at 90 degrees. All right, now a reflection across line L, so if I have this line here, line L, this is our line of reflection, maps a point P, we call that our pre-image because it doesn't have a prime, it's not in prime notation. So it maps point P to its image P prime as follows. So if P is not on line L, and we can see that right here, P is not on line L, then L is the perpendicular bisector of segment P prime. So if I have this line segment from P to P prime here, line L, my line of reflection, is always going to be the perpendicular bisector, meaning it's perpendicular because it intersects at 90 degrees, and it's the bisector because it cuts P prime, this line segment, into two equal pieces. Now that will be the same for everything, and if I look back on that figure that we were working on earlier, this one right over here, it cuts it into two equal pieces, as we can see, and that equal piece will be at 90 degrees. So this line here, this is a perpendicular bisector. So If P is not on the line, again, it becomes, line L becomes our perpendicular bisector. If P is on the line, then P equals P prime. Meaning, here's an example of it. I have Q right here. Point Q is on our line. It's on the line of reflection L. So therefore, if I reflect Q over itself, it's just going to stay right where it's at, because I'm reflecting with no distance. There's no distance to the line itself. So therefore, if it lies on the line itself, it will not move, and we can just say Q is equal to Q prime, as we see right here. And again, know that it will always be the perpendicular bisector. We can always cut it into two equal pieces, and the line of reflection will go through the middle. All right. Next up, draw a segment such that the line is a perpendicular bisector. So, what we would do here, and this is a little bit more difficult since we are in distance learning still, but if we weren't, we can use our compasses and rulers to create this. So, again, we're creating perpendicular bisectors. So I have A prime here, this line segment. I have C prime as another line segment. And then B prime is my third line segment. So again, I just connected the image to the pre-image. I just connected a line segment through corresponding pieces. Now, at this point, I would find the midpoint of each of these segments. So I'd find the midpoint of A prime, B prime, and C prime. So once I find the midpoint of all of these, again, that will be in the middle. Let me go ahead and make these points a little bit better. So it's going to be right in the middle here. And I know that it is bisecting each of these. So each of these will be congruent on either end. So I have C to the line of reflection being congruent to C prime to the line of reflection. Same with A and A prime and B prime. So again, this line of reflection is the perpendicular, meaning it's going to intersect at 90 degrees here. It's the perpendicular bisector of each segment, meaning it's cutting each segment equally into two equal congruent parts. All right, so real quick, the perpendicular bisector of a line segment is a line perpendicular to the segment at the segment's midpoint. So each of these are midpoints. Each of these purple circles here. Those are all midpoints. In the figure, line N, so in this figure down here, line N is the perpendicular bisector of segment AB. So therefore, I can also say that if I reflect point A over line N, point A will map onto point B. So, in fact, if this was a reflection, A reflecting over line N would be equal to A prime. So A prime and B could be said to be the same thing. All right. So again, we can see that right down here. The bisector does the cutting. A perpendicular bisector is a line. So anytime that we have a bisector, we know that it's the bisector that's doing the cutting. I wouldn't say that this line is being cut in half or cut into equal parts because, again, it's a line. It goes on forever. So therefore, it will never end. I can't cut it into equal parts because it's infinite in length. So it's important to remember that our line will always be doing the cutting. It won't be being cut by the segments. The segments are the ones being cut. All right, so our reflection rules, hopefully you guys remember these, a little chance for you guys to practice them up. If you could, please go ahead and write your reflection rules right over here, meaning xy becomes what? So we're starting with xy, and xy becomes what for each of these? That's what we're curious about. So try and write these down. Hopefully you remember them. If you don't, make sure that you practice these because they will come back. Now down below we have across the line y equals x, and across the line y equals negative x. So looking at these, we should end up with across the x-axis we get x negative y, so we're just flipping our y values. Across the y-axis, we're just flipping our x values. Across the line y equals x, this blue line down here, it's going to just flip our x and y values, so x becomes y and y becomes x. And then for the line y equals negative x, we will flip our x and y values and negate them both. They both become negative. And those are our reflection rules. Again, very important that you guys memorize these. These will be a lifesaver for you guys. They'll make sure that you finish the test with enough time. They'll make sure that you understand exactly where your points are going, and they'll save a lot of confusion rather than having to map each point individually. These only work when we're crossing the x-axis, the y-axis, or the lines of reflection for y equals x or y equals negative x. It will not work for the reflection across y equals 2 or x equals negative 1. For those, we actually need to use some common sense and piece together some things. But if they give us an x-axis, y-axis, or these two lines, you can automatically just plug them into these reflection rules. All right, let's go ahead and continue on. So, reflect the triangle across the given line. So right now we're reflecting across the y-axis. It's this line right here in red. So pause the video if you'd like, try this one out, and see how you do. All right, so mapping this out, I know that the distance from point M to the line of reflection is 1 unit. So therefore, from the line of reflection to point M prime should also be 1 unit. So I can do that with each point here if I'd like. It definitely will work, especially since this line is a vertical line, so I can just count over to it. See, oh, that's 3 away, so P prime must be 3 away. And then N is 1 away, so N prime must also be 1 away. And we get our figure here. We get M prime, N prime, P prime. Now again, it's important that we know these coordinate points, so M prime would be at negative 1, 2. N prime would be at negative 1, 4, and P prime is at negative 3, 3. It's also important to note that the y-axis is the same as the line x equals 0, and that our rule for the y-axis is xy becomes negative x comma y. So if M was at 1, 2, M prime, as we can see, is now at negative 1, 2. All right, let's try out another. Go ahead and pause the video if you'd like and try and reflect it over this line here. This is the line y equals negative 1. All right, so for this one, again, I'm just going to count my line of reflection. So for point M, I need to go down 1, 2, 3 units to get to our line of reflection. So M prime should be 1, 2, 3 units away. Next up, N prime is 1, 2, 3, 4, 5 away. So N prime should be 1, 2, 3, 4, 5 away. And then lastly, P prime is 1, 2, 3, 4 away. So P prime should be 4 away as well. At this point, I can go ahead and connect all my pieces together. We're going to come up with a rule for this. So we need to determine a rule for what just happened. So xy became what? Now, for this one, the only thing that really switched at the start was our y values, because I'm reflecting over something that's similar to the x-axis. So if it's something similar to the x-axis, my y values are going to flip. So I can automatically give that y a negative here. Now, if I flip M over, just flip it with the negative sign, it would become 1, negative 2, right? It'd be down here. However, we're still 2 away. So our actual answer would be x comma y turns to x comma negative y minus 2. And the reason that's 2 is this. I have moved 1 unit away from my normal axis that I reflect over, from my x-axis. So it's going to be the same rule as our x-axis, except I moved 1 over. However, remember, it's the same distance from either side. So if I moved 1 here on this side of the reflection, I must also move 1 on this side of the reflection. So that's why it becomes negative 2. Because I'm not moving just one distance, I'm moving both distances. I need to move 1 on either side. If I don't move it on both sides, then it will not be the same. So therefore, our actual rule, and here it is, our actual rule for this is xy turns to x comma negative y minus 2. And that's our rule for reflecting over the line y equals negative 1. Now, just let's say that the line is y equals negative 4. What would be our rule then? Well, it'd be xy turns to x comma negative y minus 8. So all I'm doing is I'm doubling the number of the line that we're reflecting over. So if it's negative 4, it's now negative 8. If it was negative 2, it'd be negative 4. If it was negative 3, it'd be negative 6. So again, there is a relationship between these two numbers because I'm moving down 4 from our original line, but we need to keep in mind that we need to do that for both sides of our reflection line. If I only do it for one side, then it won't do it completely for us. All right, let's continue on. Next up, we have the line y equals x. So go ahead and reflect over this line real quick, and then we'll go through it. All right, so using our rule, if I'm reflecting over the line y equals x, whoops, sorry about that. If I'm reflecting over the line y equals x, that's the same as xy turning to y comma x. We're just flipping our signs. So therefore, point P is on the line of reflection, so PP prime will be on that line of reflection. So both these points lie on that line. They're not moving. Point M is at 1, 2, therefore M prime should be at 2, 1, based upon our rule. And then lastly, N is at 1, 4, so N prime should be at 4, 1. Now if we look at this, these triangles do look like they are the same triangle. It almost looks like they were rotated across, with point P as our center of rotation. And you could probably do a problem with that. However, this is a reflection over the line y equals x. So I could probably say that this is also a rotation around point P and then find out how many degrees it actually rotated. All right, let's continue on. Looks like it'd be point P at 90 degrees, by the way. So next up is the line y equals negative x. Again, try and reflect our triangle across the line y equals negative x. So if we recall our rule here, xy will turn to negative y, negative x. We're flipping our x and y places, and then we're negating both of them. They both become negative. So therefore, I'm going to go ahead and find my points first. M is at 1, 2. P is at 3, 3. And N is at 1, 4. So therefore, N prime should be at negative 4, negative 1. So here's N prime. M prime, so M prime right here, that should be at negative 2, negative 1. There it is. Just have them all pop up for me. So here's our new points over here. So again, if I just write them out below and then I plug them into our rule, we should get our new points as well. Feel free to do this. This will actually save you quite a bit of time as you're working on problems on the test. If they don't ask you to graph it on the test, you don't need to. However, it would be helpful to have some graph paper nearby in order to plot some points real quick if needed. But this is honestly the amount of work that you'll probably need besides when you're finding midpoints and such. Again, you can use extra paper on the tests in order to use scratch paper and whatnot. All right, let's continue on. So, example 3, this one's really important. We need to draw the line of reflection and write the equation of the line. So, the main thing here that I want us to focus on is writing the equation of the line. Now, the first thing that I need to do for this, and again, super important here, can't emphasize that enough. First thing that we need to do is find our midpoints. So, I draw a line through two of my corresponding points, such as B and B prime. So I have this line here. I do the same with A to A prime. And then I do the same with C to C prime. At this point, I'm going to find the midpoint of each of these. All three of these. So B is at negative 2, 0. And B prime is at 2, negative 2. So therefore my midpoint, let me go ahead and do my midpoint in red, will be negative 2. Let's see, negative 2 plus 2 divided by 0. And then for my y values, 0 minus 2 divided by 2. Well, negative 2 plus 2 will give me 0. And negative 2 divided by 2 will give me negative 1. So my midpoint is at 0, negative 1. Next, for AA prime, well, A is at negative 3, 3. B is at, A prime is at 5, negative 1. So if I plug this in, oops, I made a mistake. 0, negative 1 should be for B, so that should be down here. And then for A, that's going to be an entirely different problem here. Let me go ahead and get rid of that real quick. All right, so for A prime, I'm going to do AA prime in blue. That will give me negative 3 plus 5 over 2, comma, 3 plus negative 1 over 2. Well, negative 3 plus 5 will give me 2, divided by itself will give me 1. 3 minus 1 will give me 2, divided by 2 will give me 1 as well. Oops, I keep skipping over. So I have the point 1, comma 1 is my midpoint here. Now, I can continue doing this and get my third point for C prime. But it's important to note that we only need 2 points in order to draw a line. So again, I can do that with C prime. I don't need to though. And since I want to make sure that you guys are focusing on getting these done in a reasonable amount of time, just stick with 2 points. As soon as you have your 2 points, you're good. If you really want to find that third point, you can, but you don't need to. In fact, that third point's right there. So at this point, I draw a line through my 2 points that I currently know. I'll get rid of that third point, pretend that's not there for now. If I draw my line through these points, we may notice something happening. We actually go through all 3 midpoints. Oops. So we actually go through all 3 midpoints as shown here. So we now have our line. Now we want to write our line in our format y equals mx plus b, where m is our slope and b is our y-intercept. So starting with our y-intercept, at what point do we cross the y-axis? Well, that's the point 0, negative 1. So b is equal to negative 1. To find my slope, we're going to use rise over run. So I'm going to go ahead and start at that point once again, my y-intercept. I'm going to see how much I need to go up and over to get to this new point, 1, comma 1. So I need to go up 1, 2. So I'd rise 2, and I'd run 1. Because again, slope is equal to rise over run. So we said that we rose 2, ran 1. So my slope would be 2. So we can finally write out our slope intercept form of the line of reflection as y is equal to 2x minus 1. Oops. Y is equal to 2x minus 1. And that is our answer. That is the answer of the equation for the line of reflection. Again, super important that you guys get this one down. If you need extra practice on this, let me know, but also feel free to keep practicing this one until you got it, because this will be an important concept that you guys need to have down. And again, here is our equation right over here, as well as the work to get towards it. If you need to pause the video right now to finish copying this down or to piece it all together for a second, please feel free to do so. All right, so next up, the figure shows one hole of miniature golf. It is not possible to hit the ball in a straight line from the tee, point T, to the hole H. I can't hit it in a straight line here. There's walls all around this. So, at what point on the wall should the player aim in order to make the hole-in-one? So I have this wall going all the way around. I need to choose the correct point in order to hit the ball so that it will make it into the hole. Well, let's go ahead and think about that for a second. We know if I want to hit the ball into the hole, I need to reflect it off of something. So my first thing that I should be doing is, how can I create my line of reflection? Well, if I draw a line from point T to point H, I now have my segment. From here, if we recall, our line of reflection should just be a perpendicular bisector to segment TH. So I draw my perpendicular bisector next. Now my perpendicular bisector needs to cut this perfectly into 2 equal pieces. Well, if I look at the length of TH, it's 1, 2, 3, 4. So therefore I cut it into 2 right down the middle. So here's my line of reflection. I'll just list that as LOR, line of reflection. So I now have this figure here. And I know the midpoint, and I can find the midpoint by using my coordinate pairs 2, 2, and let's see, that's 3, 4, 5, 6, 6, 2. So I can use the midpoint of these 2 points to find my midpoint as 4, 2, and of course my line of reflection goes through that. It must also be perpendicular, meaning that if my slope is 0 here, my slope needs to be at undefined here in order for it to be perpendicular. So I now have my line of reflection. Now, at what point on the wall should I aim in order to hit this ball? Well, if I want to hit this ball, it needs to bounce off, so it's going to bounce around. But if I hit it off the line of reflection, then it should bounce and reflect right back towards H. So that is the point that we aim for. We aim for the point 4, 0. You hit the ball at the point where the where the angle bisector intersects the wall. So, again, I hit it at the point where our line of reflection hits the wall, and that would reflect it right back to point H. Lines of reflection will be very useful for you guys if you choose to go mini golfing and you want to impress some people. And again, it's important that we know that this is the perpendicular bisector. So our line of reflection is our perpendicular bisector for our line segment TH. All right. All right, so at this point, Kara is playing pool. She wants to use the cue ball C to hit the ball at point A without hitting the ball at point B. So she wants to do a trick shot and hit to point A from point C. To do so, she has to bounce the ball, the cue ball, off the side rail over here and into the ball at point A. Find the coordinates of the exact point along the side rail that Kara should aim for. So we're looking for something called the angle of reflection. So what we need to do here is find an angle bisector using slope. So what I like to do here is I like to use slope. So I need to hit this ball somewhere over here, and when I do, it needs to bounce off and come back over. Could be up here that I hit it, could be down here. But if I create an angle bisector, it should be an equal angle on either side. So let's see what that occurs here. So if I hit point C, and I hit it over here, then it should bounce back over. Now, I like using slope a lot for this. So I see that if I go up 1 to the left 2, that will hit me to the side rail right here. And then from the side rail, I can go up 1 to the right 2, that'll get me here, and I keep following that slope because it should stay in a constant line here. It shouldn't bend or curve at all unless I'm hitting it with spin. So if I hit it perfectly at the side rail, it should reflect and bounce right into point A. Now, this angle that I hit it at, or towards, because we have our line of reflection here, that is called the angle of incidence. So this is our angle of incidence because the incident is occurring. I'm hitting it here. After it bounces and it starts going back towards A, we call that the angle of reflection because it's reflecting off the rail towards point A. So therefore, the perfect point for us on this one should be the point -1, -1. If we hit it at this point, it should reflect and bounce right into the ball at point A. All right, that is it for today's lesson. We've covered both learning targets now. I can draw the image of a figure after a reflection over the line, important. And then just as important, I can determine the equation of the line, and again, that was in slope-intercept form, y equals mx plus b, when given a pre-image and image. And again, this says mage here, it should be image. Thank you guys so much for watching. If you have any questions, let me know. Other than that, have a great rest of your day. Thank you.